Okay, this is I guess this is our seventh video on the statistics review, and we're going to talk about problems 70 through 78, I think. We may change it as we go along, but 70 through 78. So the number of sweatshirts a vendor sells daily has the following probability distribution. So they give this to us. And anytime they give me a table, I'm probably going to need to input this in the calculator. And so what we have here is we have the number, and this symbol right here is probability. So anytime there's a probability, or this is also the same as frequency. So this is probability. It is also your frequency. Okay, so that's going to be really important because we have two columns. All right, so I go ahead and enter that data, and here's how I do that. I go to Stat Edit, and here I've already entered the data. 0, 1, 2, 3, 4, 5. Those are my X values. And then I have my frequencies over here in L2, 0.03, 0.02, 0.03, etc., all the way down. Once I have that, I'm going to press Stat button, arrow over the word Calc, one variable statistics. I'll press the second button, 1. That gives me L1. For frequency, this time I do have a frequency. My frequency is in L2, so second followed by the number 2. Then I'm going to ask it to calculate. Now, what they asked for was the variance and expected value. All right. So first off, the expected value is my average. So X bar equals 1.52. Okay. Well, real quickly, that means we've narrowed this down to C and E. But we also need the variance. The bad thing is this won't give you the variance. It'll give you the standard deviation. All right. And remember, standard deviation, or the variance, equals the standard deviation, I should say, equals the square root of the variance. So basically, I need to come back and find that symbol, which happens to be 1.33, and I need to raise it to the second power. So we have our standard deviation is 1.33, but they didn't ask for that. They asked for the variance, so I need to square this. So second quit, 1.33. I'm going to go ahead and square it. I get 1.78 or 1.7689. So in this case, my answer is letter E. Please be careful whether or not it's variance or whether they ask for standard deviation. All right, I'm going to pause while I enter data. Okay, so the number of sweatshirts a vendor sells daily has the following probability distribution. What is, and this time they're asking for the standard deviation. Above, they ask for the variance and the expected value. This is our X bar. This is that symbol. All right, so I go to Stat, Edit, and I need to enter the data. So this is going to go into L1. This is going into L2. Why? Because it's my frequency. So make sure you have your freak on. All right, so I've entered the data. I'm going to go Stat. Here, you know what? I'm back up. Stat Edit. I have the data entered. I'm going to go Stat, arrow over the word Calc, one variable statistics, second one for my X list, and then my frequency list is second 2. And I end up getting an expected value of 1.45. Well, it turns out all of them match the expected value. So I need to check out the standard deviation, which is 1.2678, which happens to be letter C. Okay, please notice I didn't square it because they asked for standard deviation. Had they asked for variance like they did here, I'd have to square it. All right, so we have another t-shirt problem with another table. All right, so I'm going to have to enter the data, and this time I'll show you when I do it. Stat Edit. So I already have 0, 1, 2, 3, 4, 5 in there, but I need to change these percentages. So I'm going to up arrow, press clear, and then enter. And then I have 0.1, 0.1, 0.25, 0.3, 0.2, 0.05. And y'all probably did that faster than I did. All right. Then stat, calc, one variable statistics, second one, second two, and they asked for the expected value, which is our X bar. So let's check that out. So this is not a possibility. That's not a possibility. Okay. And technically some of these are swapped around, but let's leave them just in case. So we have 2.55 and 2.55 here. We're thinking it should be the second number, so it's probably going to need to be this one, right? It's probably going to need to be that one because it's the second number. Let's go ahead and check out our variance. So please note it asks for variance. The calculator gives you standard deviation, and it tells you our standard deviation this time happens to be 1.32. 1.3219. So we need to square that in order to get variance. So second quit, 1.3219. I'm going to go ahead and square it. And I get a variance of 1.747. All right. So these two have the same numbers, but they're swapped. What did they ask for first? They asked for our variance first. So this is my correct answer. They asked for variance, then they asked for the expected value. Be careful, that was tricky. All right, a random sample of 15 people is taken from a population in which 40% favor a particular political stand. What is the probability that exactly 6 individuals in the sample favor this political stand? So we have a random sample of 15, and we have a probability. This lets me know that because I have a fixed number of trials, I have a binomial. And we have exactly, so if I'm making a number line 0, 1, 2, ... 5, 6, 7, ... all the way to 15, I'm only circling one number. Because I'm only circling one number, this is a binom PDF, because it's a specific value. Trials in this case happens to be 15. The probability they tell us is 0.4. And our X value happens to be 6. So here's our trials, here's our probability, here's our X value. Second VARS, binomial PDF, trials is 15, probability is 0.4, X value is 6. Sooner or later, and we end up getting 0.02 or 0.2066. So in this case, letter D is our closest answer. 74. It has been estimated that about 30% of frozen chicken contains enough salmonella bacteria to cause illness if improperly cooked. A consumer purchases 12 frozen chickens. So we have a specific number of trials. We have 12. What is the probability that the consumer will have more than 6 contaminated chickens? First off, anytime I have a probability, a fixed probability and a fixed number of trials, I'm thinking it's a binom. All right, so I know it's a binom, so I'm going to make my number line, and it's going to be up to 12. So 0, 1, 2, ... 1 below the number of interest and 1 above the number of interest, ... all the way to 12. More than 6, so that means it's not including 6, but it's going to be 7 to 12. Notice I circled more than one value, so this is going to be a CDF. I should have given myself a little more room. All right, so I rewrote it. Anytime 0 is not, if you're doing a CDF, if you're doing a binomial CDF, so be careful. If you're doing a binomial CDF and you don't have 0 circled, you need to put a 1 minus in front. All right, so this is a 1 minus binomial CDF. Trials in this case is 12. Our probability is 0.3. And our X value, the highest thing we don't want is 6, because we want 7, but we don't want 6. So this is our X. So trials, probability, and X. Let's run this through the calculator to see what happens. 1 minus second vars, binomial, CDF, trials is 12, probability 0.3, X value 6. And we end up getting 0.0386. Our closest answer is 0.039. So here we go, 0.039 is our answer. Number 75. The probability that a certain machine will produce a defective item is 1/4. Please remember that's the same as 0.25. If a random sample of 6 items is taken from the output of the machine, what's the probability that there'll be 5 or more defective in the sample? So we have a fixed number of trials. This lets me know we're working with a binomial. And so we're going to make our number line sample of 6. So 0, 1, 2, 3, 4, 5, 6. Because we'd have 0 defectives, 1 defective, all the way up to 6 defectives. That there will be 5 or more, so this is what we're interested in. So I have more than one value circled. So this is CDF. Also, I did not include 0 in my circle. If I don't include 0, I have to do a 1 minus. So 1 minus the binom CDF, trials is 6, probability is 0.25, and I subtract out what I don't want. Well, I wanted to know 5, so the highest number I don't want is 4. So my X value is 4. This is my probability. This is my trials. So here we go. 1 minus second vars, binomial, CDF, trials in this case, 6, probability 0.25, and I got that because they told me it was 1/4, and my X value happens to be 4. This gives me 0.004, but we don't have answers like that. So if you remember, there's a shortcut to that. You can press the math button, and it says fraction right there, and you just press enter, and then enter again, and it gives you 19/4096. So we know that this is my answer. However, if worse comes to worse, you could divide all these out and get points until you find the one that had 0.0046. And that wouldn't be too bad either. It would take another 5 seconds. The probability that a certain machine will produce an effective item is 0.2 if a random sample of 6. Once again, we have a fixed number of trials. So this lets me know we're working with a binomial, is taken from the output of this machine. What's the probability that there'll be 5 or more defectives? Okay, so we have a probability of 0.2. So we have 0, 1, 2, 3, 4, 5, 6. This looks a lot like the last problem because we're circling 5 or 6 because it said will be 5 or more. Notice I have more than one value circled, so this makes it a CDF. 0 is not circled, so this is a 1 minus situation. My trials in this case is 6. My probability is 0.20. And my X value is the highest value I did not want, which happens to be 4. So 1 minus second vars, binomial CDF, trials is 6, probability is 0.2, X value is 4. And I end up getting 0.0016. All right, 0.0016 is my answer. All right, number 77. If you buy one ticket in the provincial lottery, then the probability that you'll win the prize is 0.11. If you buy one ticket each month for 5 months, what's the probability that you will win at least one prize? So we have some keywords. 5. We have a specific number of trials. That lets me know we have a binomial. we have the word at least, which means it's 1 minus. And if it's at least, it's also going to be a CDF. So in this case, we have 0, 1, 2, 3, 4, 5. And we want at least 1, which means we want 1 or more. All right. So what we didn't want is 0. So this is going to be my X. My trials happens to be 5. My probability is 0.11. My X value is 0. One minus, second, VARS, binomial, CDF, trials, 5, probability 0.11, X value 0. And I end up getting 0.44. So there's a 44% chance that if I play it for 5 months, I'm going to win once. That's pretty good chances. All right, suppose the probability that a cross between 2 varieties will express a particular gene is 0.2. What's the probability that in 8 plants, 2 or fewer will express the gene? I'm not even sure what all those terms mean. Well, what I do see is I have 8 trials. So that tells me that I have a binomial. I make my number line 0, 1, 2, 3, 4, 5, 6, 7, 8. And if you wanted to use ... you could. 2 or fewer. That means 0, 1, or 2. All right, I have more than one value circled, so it's a CDF. I have 0 circled, so it's not a 1 minus. Okay. And my trials is 8. My probability is 0.2. And the highest value of interest is 2. So second VARS, binomial, CDF, trials is 8, probability 0.2, X value is 2. And I end up getting 0.7969. So this is my closest answer. All right, and that's the end of this video.